Hello everyone. We are here to tell you guys what we were asked to do, and our question for today is: a particle moves along the x-axis so that the velocity v at time t equals 0 is given by v of t is equals to sine of t squared. So sine of t squared is going to be our formula for today. The graph of v is shown above. In between, t would be in between 0 and the square root of 5 pi. The position of the particle at time t is x of t, and its position at time t is equals to 0 is x of 0 is equals to 5. And our first question is: find acceleration of the particle at time t is equals to 3. So what we're going to do is we're going to first find the acceleration. Oh, sorry. So acceleration a of t is equals to v prime of t, and if you put it in a calculator, the prime of v prime of t is equals to 2t cosine of t squared. And we're asked to do it acceleration at time is equals to 3, so a of 3 is equals to v prime of 3, which is also equals to 6 cosine of 9, that solves to negative 5.467. It's negative because it's telling us that the particle is slowing down at v prime of 3. So that's our answer for that. And then going back to our second question: find the total distance traveled by the particle from time t equals 0 to t equals 3. This gives us 2 points: our 0 and our 3, where it starts and where it ends. So what we're going to do is we're going to find the definite integral from 0 to 3. Oh, this is distance is equals to definite integral from 0 to 3 of the absolute value of sine of t squared. We're using absolute value because our particle is moving up and down in the x-axis, and it's making a wave particle, so we need to take that in account. So that I forgot to put dt. Sorry. There's dt. So that's our formula, and that equals to 1.702. This is all done in a calculator, guys, so make sure you put it in a calculator. That's our total distance we've traveled.
Alright, next we're going to do C, and that's asking us to find the position of the particle at time equals 3. And we have to remember it already told us that when time equals 0, the position is 5. So when we're doing this definite integral, we have to take that into account. So x of 3 equals 5, that's what it was at 0, plus our integral from 0 to 3 of v t dt. And since it's the calculator section, that's all you really have to show other than your x of 3 equals 5.774. Next we're going to go back and do our last part, part D, and this is asking us between the range of 0 and square root 5 pi, we have to find when the time at t, when it's the furthest right, and then we have to explain the answer. So to do this, we know that at v of t equals 0 is when the velocity is 0, which means that the particle is going to be changing its direction. So because of this, we want to assess when sine of t squared equals 0. And for that we get square root pi, square root 3 pi, and square root 5 pi. Next, we're going to do our integrals for these, and we're going to go back to our position of x of t. We're going to use our big T this time, just because we have these 3 different times, equals the initial 5 plus the integral from 0 to the time we're going to assess of v of t dt. And now, to make this easy for our reader to follow along, and because it's the calculator section, we can just do a little graph of 0. It would give us 5. Square root pi will be giving us 5.895. Square root 3 pi would be 5.788. And square root 5 pi will be 5.752. And now the one that's the furthest right, as we can see, is our square root of pi. So we're going to put the message to our reader that the particle is the furthest right when time equals the square root of pi. And we can tell that because it is the largest value. And there.
I don't know how to stop it.
Yeah.